皆様こんばんは。本日はお忙しい中、ダイオキシン環境ホルモン対策国民会議の国際市民セミナーへご参加いただきありがとうございます。本日は開会のご挨拶を申し上げた後、ドイツのゲーリング博士に、50分ほどお話をいただきますが、通訳が入りますので、さらに40分ほどかかります。残りで30分ほどで質疑応答の時間を設けさせていただく予定です。講演会に先立ち、当会代表理事中下優子からご挨拶とともに講師の紹介をさせていただきます。
はい、皆さんこんばんは、国民会議の中下です。本日はお忙しい中、私どもの講演会にご参加いただきましてありがとうございます。皆さんもご承知の通り、国民会議では3年間にわたって有害化学物質による悪影響から子どもたちを守るための取り組みということを行ってきておりますけれども、今年はその3カ年の最終年にあたります。そして、私たちは最終年に提言を、作って出すということを計画をしておりましたところ、環境安全基本法という形で、その提言を取りまとめまして、皆様に、署名運動へのご協力をお願いしているところです。で、この環境安全基本法の柱の一つはバイオモニタリング制度です。この制度は日本にはまだありません。でも先進国の中では導入した国もあり、さらに導入に向けて積極的に取り組んでおられる国もあるということでありますけれども、私どもの日本ではないので、これはすでに先進的取り組みをしている国々から学んで、そのことを私どもの提言の中にさらに盛り込む形でですね、働きかけをしていかなければいけないと考えているところです。で、前回は国際市民セミナーの第1回目でしたけれども、カナダから学ぶということで、カナダのバイオモニタリング制度について勉強させていただき、大変参考になりました。で、今回は第2回目ですけれども、ドイツからゲーリング博士に、おいでいただきまして、ドイツの取り組みの状況をお話しいただきます。で、ドイツはさらにこのバイオモニタリング制度を進めた形でです。一人一人の国民の血中濃度の管理目標値というのを定めておりまして、その目標値を超えると暴露低減策を講じていかなければいけないという形で、ある意味でモニタリング調査と、それから政策とがつながりを持った形で導入をしておりまして、私はこれは日本で導入する際に大変いいお手本になるというふうに考えております。ですから今日のゲーリング博士の講演はとても私たちも楽しみにしているところです。で、ゲーリング博士についてご紹介申し上げますと、ゲーリング博士はドイツ連邦政府の環境省の毒性健康関連環境モニタリングの部長を務めておられます。ある意味でこのバイオモニタリングの、直接の担当の責任者を務めておられる方で、現職の官僚であります。で、さらに EU の欧州のヒトバイオモニタリングプロジェクト HBM4EU というものが今進行中でありますけれども、そこのコーディネーターも務めておられるという、まさにバイオモニタリングのプロ中のプロの方をお招きすることができました。このような方からお話を聞けるチャンスというのはそうそうないように思いますので、ぜひ皆様最後まで、ゲーリング博士のお話を聞いていただきまして、この学んで、そして日本でも導入すべく一緒に働きかけをさせていただければというふうに思っております。どうぞよろしくお願い申し上げます。
では講演会にあたりまして、参加者の皆様へのお願いがございます。講演資料はチャットで表示されている URL からダウンロードしてください。資料の無断転用はお控えください。本日の講演の動画は後日、当会のホームページにアップする予定です。従いまして、当日の講演の録音、録画、スクリーンショット、 などでの撮影は固くお断りいたします。先ほども申し上げましたが、講演後には質疑応答の時間を設ける予定です。質問はウェビナー画面下の Q&A からお送りください。すべての質問を採用することはできない可能性があることはご理解ください。ウェビナー終了後にアンケートが表示されます。今後の講演会の改善のためにどうぞご協力をお願い申し上げます。では早速講演会を開始したいと思います。欧州及びドイツにおけるヒトバイオモニタリング、健康な未来のための科学と政策について、ドイツ連邦環境省のマリケ・コロッサ・ゲーリング博士にお話しいただきます。では、博士、どうぞよろしくお願いいたします。
So I'm very happy that I can today introduce to you the human biomonitoring system of Europe and Germany. And I'm very happy to share the following insights with you. The German HBM system consists of 4 different components. The most important one is the Population Representative German Environmental Survey, which is a combination of human biomonitoring, ambient monitoring, and questionnaires. The second component is the German Environmental Specimen Bank, with which we can do retrospective monitoring and analyze time trends of exposure. The third component is the German Human Biomonitoring Commission at the Federal Environment Agency, UBA, Umweltbundesamt, where independent experts derive health-based guidance values on the basis of toxicological and epidemiological data. In the cooperation between the German Ministry for the Environment and the German Chemical Industry Association, new methods for analysis of health-relevant substances are developed. Here is important that the industry only pays for and is responsible for the method development, and everything what they have to do with analyzing samples and interpretation of samples is solely in the hand of the Ministry for the Environment. As the responsibility for chemical policy is in the hand of the European Commission, we have started at EU level activities to implement human biomonitoring to improve chemical policy.
Sorry.
Let me introduce our main and most important instruments. This is the German Environmental Survey, which has a long tradition, and we have conducted the first cycle from 1985 to 1986. In adults, the current survey, the GERIS number 6, has been interrupted after the successful pilot phase due to the COVID pandemics, and we want to start in 2023 with a fieldwork for the main phase. GERIS 2 was conducted first in the former Federal Republic of Germany, and then after German reunification also in the eastern part of Germany. Here the study design of the German Environmental Survey, which is a population representative cross-sectional study investigating the exposure of the German population to various health-relevant environmental stressors. And we have sampled our participants in between 150 and 300 different places in Germany. Please see here the map of Germany. And we conduct this study in a close cooperation with the health studies of the Robert Koch Institute, so that we do not have only data on environmental exposure, but also on the health condition and health outcomes. The program of the German Environmental Survey number 5, the last one was the following: a human biomonitoring of about 100 compounds, mainly new ones which have never been investigated before, and for which new methods had been developed in the cooperation between the Ministry for the Environment and the Chemical Industry Association. And then additionally, analysis of relevant organic and inorganic chemicals in domestic drinking water, indoor monitoring, and extensive interviews and questionnaires. We have found in about 32% of all our study participants a large number of chemicals, such as different reprotoxic phthalates or perfluorinated compounds. In every fifth participant, we found and in more than half of the participants, we found also a considerable number of chemicals like different metals or paraben. And this shows that all study participants are highly exposed to a large number of chemicals. And now to the study design of the German Environmental Specimen Bank. We started our first samplings in 1977 in the city of Münster. Since 1997, we sample in 4 different university cities in North, East, South, and West of Germany, approximately 120 healthy males and females aged 20 to 29 years per location, and which do not have a specific or occupational exposure. In this population, we can sample 24-hour urines, blood and serum. We have extensive self-administered questionnaires, do a dental anamnesis, and then cryo-archive the samples for the retrospective analysis. And an impression how we do that technically: we sample by use of a mobile lab, which has been developed and is run by the Fraunhofer IBMT Institute on behalf of the German Environment Agency. In this mobile lab, all investigations and also the first steps of cryopreservation can be done. And then the samples are stored in a bunker. And our biobank looks very much like the Japanese biobanks, which I had the pleasure to visit some time ago. So now the Human Biomonitoring Initiative HBM for EU. That is a European joint program which is co-funded by the European Commission and runs 5.5 years. We have a total budget of about 74 million euro, and we consist of partners from 30 countries and the European Environment Agency. All in all, 117 partner institutions from all over Europe and Israel are partners. HBM for EU is an innovative type of research program because our main ambition was to answer open policy questions as defined by EU services and partner countries. Our ambition is to give policymakers a fast and easy access to results and data and bridge the gap between science and policy. HPM4EU has already now advanced our knowledge on human exposure to chemicals by combining expertise from diverse fields of competence throughout Europe. To have comparable data for Europe, we need to make progress at different levels. One is the alignment of sampling and fieldwork protocols. Second, the quality and comparability of analytical results. And third, a mechanism for sharing data. In HPM4EU, we have elaborated the basis for this and can now collect personal data EU-wide, share and analyze them and make them available. For example, in IPChem, you can see the link at the bottom of the slide where you can access the data. Just measuring exposure levels in the body is one thing, but you also need to interpret if these exposure levels are harmful to health. That is why in Germany, about 30 years ago, we have started to derive two sets of guidance values. One are the statistically derived reference values, and the second type of values are the toxicologically, epidemiologically based human biomonitoring values. You can find the values and the methodology in the paper cited here below. Here, just as a brief impression, these are values, for example, in the first line for the plasticizer DINCH, which is a substitute for the reprodoxic phthalate DEHP, where we have derived health-based guidance value number 1 for children and adolescents. HPM1 value represents that concentration in urine at or above which we cannot rule out health effects with sufficient certainty. For the technical solvent, the pyrrolidone NEP and NMP, we could also derive HPM2 values for children and adolescents. And this HPM2 value indicates that that concentration at or above which we have to expect health effects. Derivation of HPM2 value is very difficult because often we do not have sufficient data on clear health effect in humans. We also have transferred this success model into HPM4EU, where health-based guidance values are derived by experts on the basis of toxicological and epidemiological data. They have been derived in a very transparent and inclusive way. So we have developed proposals which were then sent to consultation with national experts and the EU's policy board, so that all expertise thought helpful to contribute in Europe could comment on this proposed values. The health-based guidance values correspond to the internal exposure levels below which health risks are, according to current knowledge, not to be expected. The use of this HPM guidance values promotes the use of HPM data and facilitates the communication with policymakers as well as the general public by interpreting health impacts. The strategy by which they were derived can also be found in the literature hint, which is at the bottom of the slide. And in HBM for EU, we have derived health-based guidance values for the general population and or for workers. We have derived and consented a number of values already for plasticizers and for plastic ingredients like BPA and cadmium. We have completed consultations for technical solvents and other plasticizers, and currently the consultations are running for insecticides, solvents, pesticides, mercury and chromium. That is currently under work. But now let us have a look at results. And that is here the most challenging results from JERIS-4. We found out that for 3 phthalates which are toxic for reproduction, the acceptable tolerable daily intake was exceeded by a considerable number of our children investigated. These plasticizers have a strong impact on the sexual development and are more effective the younger a person is. As we know that these chemicals act additively, we have done a rough mixture assessment and found out that 85% of the children living at that time in Germany exceeded an exposure level which is of toxicological concern. This concerning result was reason for us to analyze the time trends of phthalate exposure by use of the environmental specimen bank, and we did a time trend analysis from 1988 until today. 2 technical points: please be aware of the logarithmic scale. And second, I'm sorry that for technical reasons, I can here only show the data until 2015. However, the time point at which we have measured the alarming exposure of children living in Germany lay between 2003 and 2006. And you can see that those exposures are here on the still decreasing part of the time trend. You can see on this analysis also the effect of regulation. The EU took different regulatory steps, first in some toys, then in cosmetics, then in toys for small children. Then phthalates were classified as substances of high concern, and today they are banned. If you look at the dark blue line for DINP, you can see that without regulation, an increase can be observed, because this phthalate was not subjected to all these regulatory steps, even though it has the same effects, but only with a lower potency. Children as the most vulnerable group are very interesting for us, and that was why we compared the exposure to the most prominent reproductive phthalate, DEHP, in between children from JERIS-4 and JERIS-5. For DEHP, we see a reduction of 75% over this 10 years. However, we still have children which in an additive mixture approach exceed health-based guidance values. The market has changed, and with the ban and the regulation of phthalates, substitutes like hexamyl-ginge were introduced. They were used, or they are used, for medical products, toys, products for children, in food contact materials, and they also have the authorization to be used in contact with food and toys. The production has increased drastically from 2002 on, when DING was put on the market, and is still increasing. We have also derived in Germany a health-based guidance value 1, which shows that this substance DING is about factor 10 less toxic than the substituted DEHP. When you look at the time trend, you see since entry into the market a steep increase in exposure with DING. Here again an example of the environmental specimen bank. This gives proof that a chemical which enters the market also enters the human body. When we look at our children and adolescents of JERIS 5, we have here the following picture. We have compared exposure for different community sizes, sex, age, migration background, socioeconomic status, and residence in East and West Germany. What I want to show you here with this slide is very typical for all plasticizers which we have investigated for the phthalate plasticizers, but also for the substitutes. And the most important finding is that the youngest children have the significantly highest exposures. And for all plasticizers, we can say that small children are 3 to 5-fold higher exposed than adults. And even though the HBM1 value is comparatively high, we found exceedance by 0.4% of the children, which means that we currently have children living in Germany which have so high DING levels in their urine that we cannot rule out health effects. 0.4% sounds low, but these 0.4% represent 4,484 children living in Germany. We have investigated also another substitute, DEHTP, which is also used as a substitute for DEHP, which is authorized for food contact material. Here you can also see a drastic increase in consumption since 2002, when the reproductive phthalates were regulated. And as expected, when we have a look in the environmental specimen bank, we see a steep increase in the internal exposure to DEHTP, which starts with the classification of the reproductive phthalates as substances of very high concern under the European chemical legislation REACH. And here is another substitute, which is DPHP. It's a phthalate with different properties than DEHP. And here again, you see an increase in the yearly consumption. All these substitutes are, according to what we know today, less toxic than the regulated phthalates, but we need to be aware that they are definitely much less investigated for their toxicological effects. But let us come back to the relation between production and consumption and the internal exposure. And this is an exemplary finding for all plasticizers which we have investigated, be it phthalate plasticizers or the substitutes I just mentioned. We have a direct relation between consumption or production and internal exposure, what means that each ton of plasticizer produced find its way in the human body. So let me conclude for this plastic additives. Exposure to old phthalate plasticizers and new substitute plasticizers is associated to production and or consumption. One finding is of concern, and this is that children are significantly higher exposed to plasticizers than adults, and that they are at the same time more susceptible to the effects of these plasticizers. Then we found out that exposure to phthalates decreased, but only when they're subjected to authorization. But what did not decrease is the amount of plasticizers in the body. This means that the children and adolescents living in Germany still have the same amount of plasticizers in their bodies, and we have just a new type of mixture, which components are less well toxicologically investigated. As we know that some of these plasticizers have additive effects, there's a clear demand for the evaluation of mixture. In Germany, we are currently working on recommendations on how to reconsider the use of plastic so close to humans that plasticizers can enter our body. Now let us have a look. That was Germany. Now let us have a look at the European level, and these are first and very first data from HBM for EU for phthalates and in children. Investigating roughly 3,000 children, we saw that the exposure to phthalates and DINCH are in the range of about 100% or a bit less. This means even though 4 of these phthalates are banned, we still can find them in all the children living in Europe. And we can also find DINCH in nearly, well, in about 100% of the children. When Germany, we look at the European scale on time trends, we can only compare 2 collections, our German Environmental Specimen Bank and a Danish collection. We have done a regression analysis, which was controlled for sex, age, education, body mass index, and creatinine. For several metabolites, we found no difference between the levels found in the German and in the Danish study. And here again, we find indication that only regulated phthalates decrease, but less regulated do not change. So much about plasticizers. Now let us move on to the perfluorinated compounds, which are persistent organic pollutants and of high concern. We have designed our research program in HBM for EU around the policy questions. And to answer these questions, we have done exposure, health research, and worked on the transfer to policy. As you can see on the right-hand side, we have done a number of activities. Inter alia, we investigated the exposure levels in teenagers in Europe and transferred data to IPChem. Then we have investigated health effects in cohorts and also mixture assessments. To transfer into policy, we first have analyzed the timelines of opportunity and have contributed to consultations of the European Food Safety Agency, EFSA, and the European Chemical Agency, ECHA, to give input, and we have elaborated a policy brief, which you can find on our website. So let us have a look at the first preliminary results, and I will start introducing our sample. We have investigated teenagers, and as you can see here, the comparison of the EU reference population and the population of our study sample. For sex, we nearly represent the European reference population. If we look at the educational level, we clearly see that in our study, much more well-educated families took part. That is a common phenomenon in all HBM studies, that we have difficulties to include people with a lower education and which have a lower income. In our assessments, we compensate that by use of correction factors and weighting factors. According to the living environment, we have a more or less good representation of the EU reference population concerning those participants which live in big cities, in medium cities, or in villages. And what came out now? Here the results for PFAS and PFOA. These are the most prominent representatives of the group of the perfluorinated compounds, which are both banned under the Stockholm Convention and under EU regulation. These chemicals have a large number of effects at very low concentrations. For the interpretation of the European values, we have compared North, West, East, and South Europe. You see on the right-hand side the exposure distributions and the indication of the limit of quantification, the average values, and the confidence and intervals. For the comparison with toxicological effects, we could here use the values from the German Human Biomonitoring Commission. And I'm sorry that here is a mistake because for PFOA it's 2 microgram per liter. The most challenging effect of these compounds is that they reduce the immune response after vaccination. What we see on these exposure distributions for PFAS as well as PFOA is that we have higher exposures in the North and West European countries in comparison to Eastern or Southern European countries. And that is also reflected by the exceedance of the HBM values, HBM1 values. In West Europe, we have exceedance for PFOA of 20% of the test population, while there's no exceedance in East Europe. This comparison clearly underlines how important it is to have European data and not only national data from single countries. European Food Safety Agency, EFSA, has derived values for the sum of 4 different perfluorinated compounds for the tolerable weekly intake. And here again, if we assess our data, we see high exceedance rates in Northern European countries and in Western European countries, and much lower exceedances in Eastern and Southern European countries. As we want to translate our data into policy, we have analyzed the exceedance rates in accordance with different regulatory statements from European agencies. If you look at the single substances P4 and PFAS, you see exceedance of health-based guidance values, well, below 10% of the population. But when you looked at combinations of these chemicals, which we find in the body, you see exceedance rates of up to 20% of the whole study population. These data give a strong support for the proposal of 6 European countries to ban the whole group of perfluorinated compounds. Now back to the more formal aspects. I said we have harmonized materials. You can find all technical information, but also substance-specific scoping documents or our training schools on the public website www.hbm4eu.eu online library. Okay, you can also find the data in the biomonitoring dashboard, which is an easy visualization of summary statistics from existing HBM data collections through the HBM4EU project. And we have 61 standardized data collections from 15 countries. You can find the EU HBM dashboard on our website. And there you can select the biomarkers in which you are interested, as well as the region in which you are interested. Just select your desired filters. Communication is key for human biomonitoring studies, and that is why we have produced a number of targeted communication products. We have all our deliverables, which we have produced in HBM4EU on our website. You can access them directly and for free. We have also produced fact sheets for all of our 18 priority substances and substance groups. We have a newsletter coming out twice a year, and we have produced posters. And also the publications can be found here in the list with a direct link to the paper. We also have reports from European workshops or research and policy briefs. But we have also produced videos for a better information of the general public on our priority chemicals, but also in an entertaining way on how chemicals enter our body. And we have a Science Digest for which you can sign in, which delivers you always with the latest outcomes and publications from HBM4EU. And now thank you very much for giving me the opportunity to share our work with you and to getting into contact. And thank you very much for the interpretation.